All right, so again, my name's Paul Long. We're going to talk about message analyzers. So this is the eventual successor for Network Monitor. And so the first thing I'm going to preface with is that while it is a successor, there's going to be features missing for a while. And as we add things, we'll try to get up to feature parity. But there are certainly some advantages, some new things we can do. And we certainly took a look at what we did before and made some advances, we think. So just some quick history. So in the past, when we worked on Network Monitor, we kind of often referred to the whole project of documentation as an archaeology project because it wasn't about going and finding the spec and reading it and creating a document for it. Unfortunately, our worlds were different back then and specs didn't exist. So what it meant is that the person would have to go look at the code, go look on the wire, write some documentation. And the problem with this is that we kind of had this multiple truths. We had a parser that was written based off the documentation. We had an implementation. There's a lot of disconnected pieces that don't really help in trying to analyze this type of data. So our goal here was to look at this and say, how can we formally describe the protocol so that we have one truth? And then generate artifacts such as the parsers, the documentations, based on that one specification. And so the advantage here is that we can start off with this one truth and have these other things that are all dependent upon them as artifacts, and they're all going to be consistent. So we could create protocol analysis, our parser, our tool that I'm going to show you today. It's just one facet of this framework. But we can also generate documentation so that documentation is always up to date with any changes in the specification, as well as simulation and the protocol itself. We can generate the stubs that are used to create the protocol. So again, we have this one truth. And so this kind of shows some of the functions and the value proposition. So visual exploration, so we can generate this model, because this specification is more than just a parser. It's a model of the actual protocol. And then we can explore those and find out, well, how do we test this? What does the model look like? We can generate the documents, parsing, all that comes out as an output. And this basically makes them very accurate. In fact, as long as it was created using the specification, it should be identical. Generate test suites. I think an overarching thing here is that since it's a model of the protocol, it's more than just parsing. It's also about behavior and architecture, where we can say, we do this request, we expect a response. We can now validate on that level as well. It's not just about looking at a single message. It's kind of looking about the behavior of a protocol and saying that's valid and that's invalid. And so Message Analyzer is a specific tool that, again, is a successor to NetMon. And it's modern. We've kind of updated the framework that we built on. It's flexible, multi-layer endpoint tracing. So this means you can capture from multiple places in the stack. We support more than just messages. We actually support ETW. How many people are familiar with ETW, event tracing in Windows? So every component in Windows, not everyone, but a lot of them spit out, I won't say debug spew, but information about the component. So for instance, you can look at DNS and find out what it's doing in the provider or at the component layer. And now you can capture this data using Message Analyzer. There are other tools to capture this data, but now that we're a primary consumer and controller of this data, that means within the tool you can say, all right, I want to look at DNS traffic, and I want to capture from the wire, and I want to see that together. And now I want to see how those interact, right? So you can now say, all right, I see a DNS request from the provider, and then there's the DNS request from the wire. Now you can sort of follow it through the stack. And so many components, SMB included, have these tracing components that give you a little bit more depth and understanding on what's going on. And so network packets, obviously, we can still open captures and PCAPs, ETW events, but then also text logs. So So we decided that a text log is just another type of trace. Why can't we create a way to read those in? So you can imagine if you're on a Linux server and you have some text logs that you'd also like to see integrated within your trace, okay, we'll do that too. You'll open up the log, open up the capture, use the timestamps to intermingle them, and now you can see that data at the same time. And so another thing we wanted to do is think about the analysis from the beginning. So I know one of the big issues, or can be a big issue, maybe not with you in particular, is the amount of data you have to look at. So you might have gobs and gobs of traces. Maybe somebody's been running a trace for 2 weeks now, and God forbid you have to load that 25 gig file into Wireshark or something. It's just not going to work, right? And so we have this new paradigm of how you collect this data and kind of look at it at a high level called browse, select, view. And so what this means is you might say, all right, well, I've got chain captures last 4 weeks. Okay, we'll browse that data. We got some ETW captures, some log files. And then so you pull it all in, and we haven't parsed it yet. We're just sort of giving you some cursory information. And so now you can look at it and say, all right, I want to look at this slice of time, this 5-minute window, because I looked at all the logs, and it spans 4 weeks, but I'm really interested in this time. So you move some sliders over, and you say go. And now we're just going to load just that 5 minute at a time. So using parameters, metadata like that, you're able to kind of take this big lump of data and then narrow it down without having to do a full parse. So it's another way to explore large data sets without having to be fully parsed before you can look at them. And then we've also changed the way you look at the data, and we're going to go into demos in a second, but we have something called operations, which are basically a high-level view of the data, and we'll show that in a second. We want to bubble up errors that occur down the stack so that if something happens at TCP or SMB, and you've got 10 protocols on top of it, you can kind of see those errors percolate up so you can dig into them. We have a way of on-the-fly grouping, which is kind of like the conversation tree on steroids. It basically allows you to configure your conversation tree however you want it. And this becomes really powerful when you want to look at things like, all right, I want to look at SMB traffic, but I want to group it by the file name. I want to see how the traffic relates to the file name, not just TCP port or an IP address. And then we have some other cool things like payload rendering, which allows you to look at a payload in its native format. So rather than show you pictures of the tool, I'll show you the tool. And it's actually been updated since those pictures anyways. So we have a similar concept, the start page. And then we can quick open a file, but then we have these new activities that you can do. So the browse one is the one I mentioned before. So let's say you have a bunch of logs that you want to view. And in this case, I want to view Azure Fabric logs. So our Azure team has these text logs that spit out data based on nodes of machines, clusters of machines. And they have this idea that they have tenants, which are users, like a service or a website or something that's using the machine. And then they have blades, which are the computers or the nodes that are running. And so these things are all load balanced and whatever. You know, the tenant says, okay, here's my tenant. And you go, all right, well, that's going to run up over there somewhere. And so now they have this problem in Azure that a tenant calls up and says, hey, my program's not working, or my service isn't working anymore, and they got to go troubleshoot it. And so now they got to look at all these logs from each node and try to figure out how they map together. So we worked with this team, and we decided that we could just read their logs in and group those together. But so what I'm going to show you is a demo about that, but I'm going to do it using this browse select view. So we have this data, and look at the size, because that's kind of, so each of these are almost 10 gigs in size. 10 megs in size. So it's a lot of data. I've selected a lot of it. I'm going to open it. But like I said, we're not going to parse all this data. All we're going to do is kind of bring it up there, show you some cursory information, and then we enable this start line, time filter line at the bottom. So now that I've selected them all, you can see that the timeline's populated. It tells me I have, close to 1.7 million messages. And now I can narrow my timeline down. So for instance, the customer tells me that, well, I know, between 820 and 825 seems like to be where the problem occurred. And so now once I've narrowed that timeline down, the messages have dropped considerably. Now I could also apply a filter so that when I read in this data, I'm not pulling in a bunch of stuff that I don't want to see into into memory. And then you can also envision in the future that we have other types of metadata. Like, for instance, we could say process. Maybe we can show all the processes up there and you say, okay, I just want to see Internet Explorer process traffic, and we only bring that in. So this is this idea, again, that you have lots of data. Let me just look at little pieces of it until I figure out what I want. And then once I view, it'll bring just that data into the analysis grid. And so now we're starting to get the meat of the display, which doesn't look that much different than NetMon. Well, it looks a lot different, but it's the same idea. You have a summary view. Click on the summary. You get details, and details will highlight the hex data on the right side. But what's different in this case is this is a text file. It's not a capture file. This is just text data here. In fact, in the hex details, that's all you see. But we display it in the same way. It's like any other capture data. As we have summary views with rows, and then we have details. And so you can take any log file, configure some parsing around it, and I'm sure we'll put a lot in the box, but it's pretty flexible. It's regex-like language to define how to parse these things. And then you can view any of these log files in the tool. So, next thing I want to show you. Let's.
A real quick question.
Yeah, sure.
You're talking about grabbing text files from Linux, for example.
Yeah.
Do you have the capacity to be a syslog receiver?
Well, yeah. So. We're working on that. So what we want to be able to do.
So you should be able to get syslog.
Yeah, exactly. So I don't know how it would work on a Linux box because this is only going to run on Windows for right now, our product. But the idea is that you can monitor a log file. Say I want to look at that log file and get updates live. So look at like a live stream, and I imagine you do that over the network maybe. So that's a possibility.
Syslog can send its logs over a network connection.
Well, are they just text logs?
Yeah.
Oh, okay. Yeah, as long as it's a text log and as long as something that and this would be interesting to get feedback. The feature we want to do is if a log is updating live, we want to be able to look at it like a live capture source.
That's what, yeah.
So as long as that, okay.
That's what I'm asking. So great, thank you.
Yeah.
That's good.
Everyone, the question was, can we read? Linux has a way of updating logs live, and whether or not we'll support that. And the answer was what I just said. Okay, so. One of the things I mentioned in the beginning is that we have this idea is we can expect data from multiple points in the stack. And so what this means realistically is that you can look, in fact, what I'll do is let me hit another activity, capture. You can capture data from the link layer. So the link layer is just a regular network NIC card. But we've decided that maybe it's important to look at other places in the stack. So for instance, do an HTTP trace, and it's encrypted again. So we thought, well, rather than doing it after the fact, which still might be a useful scenario, what if you could collect that data before it was encrypted? Well, we looked around, and somebody had already solved this problem. There's a tool called Fiddler that actually acts as a proxy and captures this data in the middle. They exposed some API. So we said, well, why don't we just make an ETW provider that takes that data and spits out HTTP traffic? And so we include in the product, we intend to include HTTP proxy. You can capture from the proxy, meaning that you'll see all that traffic unencrypted. So that's pretty neat. But maybe it's not just for network traffic. USB is just another device that talks over a wire. So we can read traffic from USB. And in this case, it's the provider. It's this component traffic that logs whatever it wants. But it's conceivable that they can log payloads. So if you plug in an Ethernet cable over USB, that you could also see that traffic from the USB provider. So it adds some interesting possibilities in the future. And all these ones are built-in profiles. I'm going to show you in a second that you can make your own profiles based on the providers in the machine, but these are the ones we include. So firewall allows you to capture at the firewall stack. So what this means is if you're doing encryption on the wire like ESP, this allows you to capture above that level and see the traffic before and after. Again, it's encrypted. And so the last one here is not in the product, but should be or will be sooner or later, and I've added one manually, is an SMB client provider. So the interesting thing here is that we've worked with the SMB team to have them log their network traffic as well as this other provider traffic in their provider. And there's a client version, there's a server version as well, and they both work very similarly. And so what this means is that if you're using SMB3 and encryption, we can capture that traffic unencrypted as well because we're getting it from the provider before they even encrypt it. So for troubleshooting issues where you want to look at SMB traffic encrypted, this is a great way to look at that data. So what we're going to do is a demonstration with this client. Yes, question.
So in Windows 8, you've got other buses, right? I2C and so on. Is there an opportunity for sniffing those, just like USB?
So what other are you talking like direct SMB?
No, I mean the Bluetooth. And
Oh, yes. Okay.
There are various other.
Yeah. So the question is there's other buses that SMB can travel over. The SMB client provider is above all of that. This is basically glommed onto the client, sending out the events before they even get to anywhere else in the stack. In fact, what you'll see in the demonstration is that we have this ETL blob and an SMB right on top of it. There's not an SMB, an IP or TCP or anything under it. So yes. And in fact, SMB Direct is another case here. If you have an SMB Direct card, well, that's all direct memory. Nothing goes on the wire. It's basically impossible to see. But if you get it right from the client, before it gets to any of that, you can see the data. Now, of course, there's probably a performance issue. SMB Direct I saw crazy demos of ridiculous speeds. I think at some point, your machine, there's going to be a problem trying to capture that data anyways. But the idea there is that we could work with the SMB team, provide some filtering options at the client level so that you could say, I only want to see this user. And then you go configure the client. So you'll notice, and this kind of segues to the next part of it, is you notice there's certain options here that I can configure, keywords to turn on certain options. In fact, if you click the button, it shows you what those options are and their names, so you can see how I have them set up. But there's other options. For instance, I know I saw, maybe it's on the server side, there's an SMB Direct thing, and I don't know what it does, but there's other options you can turn on. So conceivably, they could expose keywords or ways to configure the provider to get more filtered information.
So actually, the other question I had was that you are tracing HTTP and SMB, right? Are there other, in Windows 8, are there other kinds of protocols that are coming up for other uses for which somebody may want to sniff?
Yeah, so the question, so the question is are there other protocols and other places in the stack that you can sniff and get other information? So the answer is yes. Our goal is to kind of work with these groups to make them useful, at least to get the protocol level. For the most part, providers, this debug information is like, okay, we're going to set up this TCP socket. We're going to send, but they don't usually put what's on the wire. We worked with SMB team to get this done for SMB. You can actually see in this list, so this is the list of providers that are available on this machine, and this list is very long, by the way. You can search. So for instance, if I wanted to look at DNS information, I could find the DNS client provider. Now I know that they don't put their packets on the wire, but you can create a profile that has both the DNS and SMB client together, or maybe the DNS and the NDIS or the firewall or HTTP proxy, and see that traffic together to get some idea. But in the future, that would be what we're aiming for, is to have these clients, for HTTP, rather than use HTTP proxy, why don't they just give us the unencrypted data? Yes?
Does any kind of global configuration have to be done to enable the sniffing of the underwire or pre-wire data?
So that's a good question. So is there any setup information, any anything that has to be done in order to see this data. And so I think the question comes, maybe a good question that's related to this is, can any user just see unencrypted traffic, right? I mean, so what we've done is we're setting up security groups in which the users have to be in order to see this data. And so I think it's an obvious precaution. In fact, probably couldn't ship without this. In order to protect that private data, there has to be some gates in which users can be restricted and have to be an administrator or part of these groups, really, in order to see that data. Does that answer the question? Anything else? Okay, so for this example, I'm going to actually, so we have the SMB client provider. I'm going to actually modify this and add this firewall provider in as well. Someday I'll do it the other way because I don't remember. So now I have both providers. And I'm going to go ahead and start a trace. Cross my fingers. Too many beta products running at the same time. And so now we have traffic coming in. So the next thing I'm going to do is there's a share. I hope this is the name. That's been encrypted. Oops. That's the name of your machine, Neil. S4?
X8
S8.
X8-8400.
And so test share has been encrypted. I'm going to open up a file here. And now I'm going to stop the trace. I try to verify that I captured what I want.
Technically speaking, Paul, I think you mean that the share is sent, the traffic to the share is encrypted.
That's right, yes.
The SMB level encryption.
That's right, because I'm on the client, and the server is what I'm connecting to.
So you couldn't capture a firewall sensibly.
Right, well, right, and that's the idea. I'm going to show that the firewall is going to be encrypted, but the SMB client is going to show visible. And so now I've captured some traffic. And so what's kind of cool is that it's the same parser. I've basically captured it 2 different places that are going through the same parsing logic. And I've created a filter. So this is the same kind of idea as Network Monitor. We can create filters. And now I see the traffic parsed from 2 layers. So you actually see 2 tree requests in a row. So we're going to talk about a bunch of things here, but we'll start with the original topic as far as encryption. You'll see that in this case, the first line shows both the source and the destination. So I know that that's from the firewall, because from the server standpoint, the server the client's SMB client provider doesn't really have the source information in its packet. So we just make that this local address, this 01. So this first one's from the firewall, and the second one is from the SMB client provider. So now I can see these 2 together to understand that the traffic is related. So I'm going to dig into some other kind of message analyzer specific things, and we're going to get back to the encrypted traffic. So you'll notice these blue boxes, and in fact you'll probably notice that I only have an SMB tree connect. There's not like a connect and a response, right? So I told you before that we have this idea of operations. And the idea here is to take a bunch of traffic and try to condense it in small space as possible so that you can understand things at a high level. So what we've done is this notion of operations allows us to condense a request and a response into one thing, and then create a summary line that's kind of tells you the full story at a high level. So you can see there's a tree connect, and then it was successful. Now I can break this open and I can see the details if I want. And now I can see that I have a tree connect and a tree response, and then so on. You can see the layers of traffic underneath. In fact, we have a view called the stack view. So I'm going to click on, this is the firewall. If I click this, the blue box, it gives me the stack view. So from the firewall perspective, I can see that we have an operation that consists of a request and response. And then at kind of a high-level view, I kind of see everything that's going on. I see that, okay, well, we had a bunch of, let's see, is this, I'll find another example. But if there's a bunch of fragments, you'd see a bunch of boxes at the TCP layer for all the fragments. So already you notice that we've done this all for you. All the reassembly, all the fragmentation, all that stuff is hidden from you. And we're showing you the top layer. We're kind of showing you the application layer first, and if you want to dig in the details, you'll be able to do that at a later point. But we think that for a lot of our audience, understanding this high level first and then digging in is an easier way to look at things. So that's the idea of an operation. So now we have all this SB traffic, and I want to find out where my file was. I mean, this file that I just clicked, I want to find it. So we talked about grouping. Grouping is a way of creating this virtual grouping of data so that I can organize the data any way I want. So what I'm going to do is I'm going to go find something that is SMB file name property. And we have this this thing called column manager. It basically allows you to explore all the names in our space. The thing that makes this easier is you can search. So maybe I don't know what it's called, but I just know it's called file. It's probably called file name somewhere, and it gives me a lot of options. I can go through the list and look for SMB file name. That's probably the one I want, right? So I'll go ahead and add that as a column. So now you can see that the column name is populated. So now what I'm going to do is group by this column. So now what I've done is I've sort of organized this data and grouped by the file name so that I can see all the files that were referenced, and anything that referenced that traffic is collected under that group. So now you can see I can do this for any data. It's not, I mean, you can create trees of any depth using any sort of pivots, and it allows you to organize your data in any way. And so right here you can see dearlist.txt. Well, that's the one I double-clicked and opened up. I can open it up and find all the traffic that deals with that particular piece of traffic, that particular file name. And at a very high level, I can look and say, all right, we did a create, some reads, queries, some more reads, queries, and the close. So the whole conversation is kind of wrapped up around that file name.
So how is the traffic from the other side not showing there?
So this is, so the question is, how is the traffic from the other side not showing? So this is the operations. So this is showing you, again, the high-level response and request. So
it's
the
not
source,
showing the response, it looks like.
yeah. So the source and destination is based on the first message,
Oh.
and then you have to dig it open to see the request and response. So it's kind of, for source and destination, what do you put? Is it, you can't put it in both directions. So we put, the initiating message is the one we used here. But you can break it open and see each message. We have time elapsed column. So now you want to look at performance. Time elapsed basically takes this collapsed group and determines how long it takes for that whole operation to occur. So now you can kind of quickly look at this. You could sort on this column and go find, what took so long? What operation took the most time? So a very simple way to do performance as well. So the thing you might notice is that, as I said before, source is this 01, this local address, but I don't see any of the firewall traffic there. If I did, I would have seen, the real source address. And of course, you don't see it because it's encrypted. I mean, you wouldn't expect to see it, right? That's not to say it's not there. It's just encrypted. So I'm going to click on a message to kind of have some context. I'm going to remove my grouping. And then we'll see what the traffic looks like without the encryption. And so, of course, you see here that we have a read, and we have this SME2 thing called the transform. And this is what you see on the wire for these encrypted shares. This is the information you want to expose using the SME client provider. So you can still relate this stuff to what goes on the wire if you wanted to understand if you had some performance issues on the network itself, but you can't decode it. Now, another interesting thing I found out is that they have this session ID. And so I can use this session ID, apparently. I can group on this. And if there are multiple encryption things going on, I could group them by this session ID to kind of group those things together. In this case, I think I'll probably just have one, but I don't know. Other things could have.
That's really cool for multi-channel, because there's all kinds of session IDs on that same TCP connection.
Exactly, right. So if you have a multi-channel trace, this could be used to group the stuff together so you can see related traffic, even though it went out over 2 NICs or 2 different ports or whatever.
Is it possible to show it in the time sequence for multi-channel, or
is it possible to show the
right sequence?
So yeah, so the question is it possible to show in the right sequence for multi-channel? So this is a feature that we're working on to actually do a better job of correlating this data. We use the timestamp of the packet. You can sort on anything. So you could sort on timestamp. I'm not sure that that's always going to be a reliable measure of the actual sequencing. I mean, you'd think it would, but I'm sure there's lots of variables there. But in the future, we want to be able to actually use more information to correlate traffic in case there's other things in this.
Hey, Paul, I had a question.
Yeah.
You mentioned in passing that you could show the time it took to do an operation.
Right.
So for storage, that's what we call latency.
Right.
Can we sort the display by the latency of the operations?
Yeah, so the question is can you sort on the latency? In this case, our latency is called time elapse, which basically is the time it takes for, it's the difference between, it's the difference between the first and the last message.
Right.
So yes, you can sort on that column and then have the highest latency item show at the top.
Cool.
Yeah. Yes.
Can you plot that in a histogram and show the... No.
So, yeah, not too far.
Do you have
That's a
anything at the
storage
server
analysis tool. That's
Right.
just
Yeah.
Do you have anything on the server side?
Yes, so the question is, do you have anything on the server side? So SMB client is one option, but there's also the SMB server piece as well. So it works the same way. If I do a search for SMB, you will see that we have the client server. We have SMB direct actually as well, which just shows the direct level traffic, but probably not that useful. And then inbox will probably ship both of these, so that you'll have the profiles on the right side that you could simply just select and go. But you could always create these things yourself if you wanted to mix and match things. So let's go back. So we talked about grouping. We talked about operations.
Hey, Paul.
Yes.
Could you open the stat on one of the reads just to demonstrate?
Yes, okay, that's a good one. So we have something that is certainly going to be fragmented. And in fact, well, let's see. It might not be let me open a different trace for that. So on the wire, that big packet probably would have been split into a bunch of pieces. But of course, those are all SMB transformed. And in fact, those could have been fragmented. But at the provider level, it's just one big chunk. So what I can show you so this is a trace I'd taken before of HTTP traffic. So now I'll filter on HTTP. And so another kind of interesting thing that's different in this world than in the Netmon world, so when you filter an HTTP in Netmon, those fragments, wherever they were, would not be included in the filter. Like if you did a filter and saved it out, all those fragments could be TCP. They wouldn't be identified as HTTP, therefore wouldn't pass the filter. Message analyzers, that's not the case. I type in HTTP, I see all HTTP traffic, regardless if it's a fragment, as long as we put it together correctly. So now I'm confident that when I type in HTTP, I'm seeing all the HTTP traffic and all the fragments that are related. So again, we have operations at the HTTP layer. A request and response get bubbled up into one, so now my traffic's nice and small, concise. I can read through what's happening. So I can take this GET request and look at the stack. And so, again, you see the operation at the top. You see a request and then the response. And what's interesting here is that the response is actually made up of a bunch of TCP fragments. And so this view, this stack view, is kind of interesting because right away it tells me, okay, a bunch of fragments came in. I can actually go view those by cracking open each layer. So now you can see that we have a TCP request. We kind of virtualize this. And then you now see all the requests and their lengths. So all the fragments are there. They're underneath there. They're just kind of tucked away, out of the way until you have to look at them. And so that's a pretty neat, I think a neat view. It's a very simple thing to work with, especially when you just want to dig into data and see things at a high level. All right, some other notable things that are interesting. So I told you that we have this idea of viewers for data. So what that means is that it's called a field view. But basically, if there's some special way to visualize something, I can click on the payload, for instance, in this operation. In the operation, we sort of exposed some details that we thought were useful. Not all of them, just some of the cool ones, and payload is one of them. When I click on payload, the field view now has that text file there. I can now read it. I don't have to go look at the hex and figure out what's going on. I can read the whole thing. I can copy and paste it and move it into something else. But that's not all. So let's say that we had an image. I can actually see the image as well in the field view. So the idea here is that it allows me to visualize it in its native format. Now this works actually today now for XML data. If I clicked on, maybe I can find one if I'm lucky. I can see the XML view as well. So now I can explore it as XML. So the idea here is that I can view it in its native format so that I can get a better grip of what that data is without having to go look at the binary format or whatever. And so for now, we do the bitmaps and the XML data and text files. But you can imagine that you wanted to troubleshoot some audio stream and play the audio stream back, so maybe it would play, or a video, or remote desktop. Maybe you want to see what the mouse was doing or something. Lots of cool options here. I don't know how far we'll go depending upon the needs, but I think there's lots of cool things. Like SMB files would be another obvious thing if you wanted to see what the file was. So kind of a cool option to give some visualization aspect into the data that you're looking at. So I want to look. So I'm just going to go through the slides to make sure I didn't miss anything. So we talked about the payload rendering, the operation stack, the ribbon. So I didn't really talk about the UI in general, but we're using this ribbon control now. And I think one of the cool things with the ribbon is you double-click any ribbon and get it out of the way. So you get automatically more vertical space. And I think this is for a protocol analyzer, people want width and length. I mean, they want as much space as they can get. So I like the way the control gets out of the way. Talked about grouping. Okay, so validation, this is another one I wanted to show. So we talked about bubbling up errors to the top. You want to kind of look at your trace and say, all right, is there something wrong? I want to know if there's an issue that I need to look at. So I'll open up this capture. And so you'll notice this column here. We have a diagnostics column. And what we've done is we've decided to identify certain issues and bubble them up as a column. And so the obvious one is a validation error. The protocol has done something that's not to spec. And so we'll bubble those up. But we can also bubble up interesting errors. Perhaps you want to look at SMB errors. You want those to bubble up. And maybe there's some that you do want and some that you don't. We can at least at a high level decide what those are. And then we can also bubble up errors that might parsing errors. Perhaps your protocol is so off that it can't even be parsed, causes a violation, some sort of captured exception. And those would also be flagged in the diagnosis error. So, like anything else, you can group on the diagnosis error. I tend to group a lot now. In fact, I group on protocols to see what protocols are available and dig into the protocols, or the module, as it's called here. But in this case, I grouped on diagnosis just to say, okay, most of them don't have any, but a bunch of them did. So again, I click on the message and I see the frame. I can click on it and see that the validation error is that this message exceeds the number of granted credits. So what's more interesting in this case is not only it's a validation error, but this is a validation error that occurs over a sequence of messages. So it's not like looking at one message and in that context, finding a validation error like it should have been 4 or 5. This is actually saying, all right, we negotiated a certain credit level, and then after a while, some messages violated that credit or exceeded the number of granted credits. So we can find validation errors across sequences of messages, across the behavior of the protocol, not just a single message. So this kind of gives even more flexibility to find problems with protocol implementations, again, without having to read the code, without having to dig into the details. We'll bubble them up for you, assuming that it's been identified. And in the case where we wrote the protocol with our specification, those are all built in. So it'll be a very nice system once we have it end-to-end. But even for SME3, we can put in the most popular things to find. And of course, these errors bubble up. If they're buried way down in TCP, we bubble them up to the top so you can find them easier and then dig in once you find it's relevant.
Like TCP retries or something like
exactly.
that.
Yeah, exactly. So that's one we just added. So the question is, TCP retransmits will also show up. So for instance, I think a very common scenario would be that maybe you group by diagnosis, and then you see an error, you click on it and say, oh, that's a TCP retransmit. You go look at the high level, you see, oh, right, the time elapsed was 3 seconds. That's ridiculous. And now you go in and look at the TCP retransmits and see if they're, obviously probably at that point that's the issue.
So a specific problem that we are having somewhere is that at the Azure interface, the NVGRE packets are getting fragmented and they are not being accepted by and that's like, we don't know what is going on.
Yes, that's a good example. So the example he gave is that the Azure, some Azure component is fragmenting messages so bad that the results can't be put together and they can't figure out what's going on. So in our UI, those could be shown as a diagnosis, and right away you say, all right, there's some problem here at a high level. I can go at least figure it out. So again, it's kind of alert you about these things that you don't know are lurking below the scenes. And so I showed you column chooser. Grouping can be multiple levels. It's not just one. You can do as many levels as you want. Details view, we want to try to make these things collapsible. So again, they get out of the way. This is the browse select view I told you about, so we showed that. Just to kind of give you another example of a different kind of trace, I could open a USB trace. But again, it looks exactly the same. And by the way, I talked about log files before. I create a parser. Well, if it's already tab delimited, I think, or comma delimited, we'll open those automatically. So for comma delimited files, you get the parsing kind of for free. But if it's something more complex, you might have to write some code around it. So here's a USB trace, and just it looks the same. I mean, it's basically just a bunch of messages with a bunch of details. And you can add, you can click, you can filter. It's the same thing, right-click filtering. So it adds the filter for you. We tried to do some work on some of the filtering, and Network Monitor became really long, some of the lines coming. So we're doing some work as far as how you write these filters so that they can be more compact. You don't necessarily have to write the whole thing out. Sometimes the first and the last name are enough. But again, the traffic's the same. You can do all the same operations on a USB trace, DNS, ETW, any ETW trace that you find in that list you can look at. Another cool thing I just thought of is, we also have an idea of, so in Network Monitor, this was actually a pretty common request, is, sometimes you identify things with these friendly names. So we'd say protocol equal UDP, and then we have a number associated with it. And so you wanted to create a filter, and this is not 100% working today, but we can now use the enumeration name. So when I say equal UDP, it knows that's an enum, and so now we have friendly names for the right side of values. So you can imagine like SMB commands, we can use friendly names rather than having to memorize these numbers that I'm sure you all probably already have, but in any case, you'll have that option as well as the regular option. And I guess the note here is, as far as the ETW manifest, so we have parsers that we write for SMB, but for the ETW manifest, we actually generate those on the fly. We look at the system, we say, all right, what's the manifest information? We build these parsers on the fly. So you might notice that they're not included, there's no parsers for them, but they get generated automatically. And I think the interesting thing that we're looking to solve is that you might have a Windows 8 machine and give it to me, and I'm on a Windows 7 machine. Well, we plan to have some of that information about the manifest in the trace so that you don't have to go, figure out how to get the right parsing on a different machine. All right, so discussion. I already did demos. I guess the discussion here between you guys is understanding what will help you and your customers. We want to make sure, get your feedback. This is a tool that's not released yet, as Daryl mentioned. And the scenarios you use it for. So I know the decryption scenario comes up all the time. It'd be interesting to see how this way of solving the problem addresses that issue for you as well. That's really it for the talk. Are there any other questions? Oh, great.
Yeah, when will this be?
I knew it. I was waiting for that. I should have just said it. So the question is, when is it going to be released? So our plan is to release it in mid-September, actually for SDC. Yes. That's
another reason to show up for SDC.
That's right. Yeah. So we hope to have something released, some sort of technical preview, something that we'll do a public release of. And that's our intent. And I think we'll be able to.
Did you want to? Yeah, sorry.
Sorry about that. So does everybody know SDC is Storage Developer Conference in September in Santa Clara at the Hyatt? And that's the co-located Plugfest. Paul will be there and showing off the stuff. So this is your first opportunity or your next opportunity to see all the Microsoft experts. In many cases, we actually have more people there than we have come over and speak here. And of course, there'll be about 100 people in the CIFS SMB SMB2 Plugfest, and Paul's stuff will be even cooler at that point.
Yes, there are some
how can they
surprises
get
still.
How can they get the materials after that?
I don't know. I don't know that we've shared. You mean as far as the beta?
What's the distribution method going to be?
We'll probably have like on Connect some sort of downloadable version on Connect is probably what we're thinking right now, which is our Microsoft's download service. So I don't know. We'll have to figure out exactly.
Right, and you can expect that as this progresses, just as we talked about with the Netmon parsers, we will update our Microsoft.com open specifications, applied interoperability tools page, and there's an actual landing page that Paul updates when we have a final version of Netmon, for example. It's downloaded from download.microsoft.com. If we've got a beta, it'll be on the Connect location. So our parsers that we'll be delivering to you very soon will be on the Connect location, which is also where we put our test suites. But if you ever have a question, just go to the Applied Interop page, landing page, and you can find all of the links there.
Any other questions? Great. Hopefully we see it, and if not, look for the release around that time.
Okay.